Okay, so yesterday we learned how to do slope, rise over run. And we're actually going to do the same thing today. It's just called something different. So constant rate of change. Okay, rate of change. Make sure you write what I write. Rate of change is the same thing as slope. Same exact thing. And what did we do yesterday to find slope, to calculate slope?
We plot the points.
Yep, we plotted the points, and then what did we do?
Drew the arrows.
And then what?
Then
Divide what?
run.
Yes, the rise and the run, right? So slope is the same thing as rise over run. All these things are synonymous. Rate of change, slope, rise over run, all these are interchangeable. Okay? Now, the fact that it's a constant rate of change, I'll come up to the top, means that it is proportional. Proportional. And if it's proportional, that means it's linear. Linear. Can you see that? It's parentheses and then linear. If it's proportional, it's a straight line, it's linear, and goes through the origin, which is what all of our examples are today. They're all proportional. They're all straight lines, and they go to the origin. Oh, also, I didn't mention this. It just popped in my brain. But rate of change, slope, rise over run is also the same as the unit rate, which we've already done before, right? Like miles per hour, the price per box of diapers. Remember us doing that? The price per pen in a pack of pens. That's what you're doing, just on a graph. Instead of using ratios to solve it, we're using slope. Well, technically, this is a ratio, because ratios can be written as a fraction. It all intertwines. Okay. So, now that you've got how in the world this ties in, now we're going to apply our knowledge from yesterday. Okay? So let's look at number 1. The cost of individual roses sold at a farmer's market is shown on the graph. Okay, so let's look at the graph. So what's really important is you have to pay attention to what is being compared. Okay, the units. So we're comparing the number of roses. Okay, and I see they're going by ones. One rose, 2 roses, 3 roses, 4 roses, 5 roses, so on and so forth. We're comparing the roses to how much they cost, which is money, right? So this is $3, $6, $9, $12, $15, so on and so forth. Does that make sense? Yes. Okay. Alrighty, so we are going to see what is the constant rate of change, aka slope, aka rise over run. Okay, what is the rate of change? What is the relationship between the roses and how much they cost? FYI, if you didn't know, roses are expensive. Like if you're gonna buy a dozen roses for somebody for anniversary, birthday, Valentine's Day, get ready to drop at Lisa Benjamin.
Oh, this.
For real. Not kidding. Alright, here we go. I mean, y'all know Benjamin Franklin's on which dollar? Okay. Just make sure you understood the reference. Oh, you know, okay. Anyway, so we're going to rise over run. The problem is, as Bella mentioned earlier, with what we learned yesterday, the first thing we did was plotted points, right? Here, the graph is already plotted for you. So I don't see any actual points. So we have to find our pretty points. Okay. So we need to find to, this is what I call pretty points. Pretty points are points on a graph where I know exactly what the coordinates are. It's not like halfway in between any lines. It's perfect coordinates with whole numbers. I don't want any decimals or fractions, okay? So, for example, I see there's a good bit of pretty points here. I see a pretty point at 3, 9. You see how that's a pretty point? It's not like halfway between anything. It's perfectly on 3, perfectly on 9. So I'm going to write that down. We're going to do 3, 9. And can anybody find another pretty point?
18 and 6.
Oh, make sure you go in the right order.
And 6 and 18.
There we go. Have your X go first. 6, 18. Yes. Now, apply that to our situation. Our X's are talking about our number of roses. Right? That's what our X's are. The number of roses. And what is, I need a darker pen. Whoa, whoopsie. And what is the Y representing? What does that 9 mean? What is the Y-axis? We circled it earlier. What kind of numbers are these? What do they represent? Yeah, it's money, right? So this is money, and then the other one, the other Y value is money. So now relate that to real life. 3 and 9 when it comes to roses and money. What does that mean?
You get 3 roses for $9.
Yes, exactly. And same thing with the 6, 18. What does that mean?
You get
6 roses for 18.
Yes, very good. So when we calculate the rate of change, we're figuring out the unit rate. We're trying to figure out the cost per rose, right? Remember us doing that a couple months ago? But the way that we're going to do that is by doing slope instead of using ratios.
I have a question.
Yes.
Do you always only find 2 of them?
Yeah, you only need 2 pretty points. You only need Romeo and Juliet.
So
No other
you
lovers.
just pick 2 random.
Pick 2 any of the random ones because it's going to be the same no matter where we do it. And I can show you later.
27 if I want to.
Yes, absolutely. Yeah. I'll do another one on the same line so you can see that it simplifies to be the same thing. So let's go ahead and do rise over run between these 2 pretty points, and then I'll do another set of pretty points, and you'll see how it simplifies. Good question. Good point. All right, so we start with Romeo down here. He's trying to get to Juliet, but he can only walk it, right? He can only travel vertical and horizontal. So we're going to rise, but be very careful because this is not 1. What is my y-axis going by? Going by 3. So this is 3, 6, 9. Do you see that? I have to count by 3s when I rise because my y-axis counts by 3s. So I rose 3, 6, 9. So my rise is a positive 9.
It just depends on what it's got.
Exactly. Absolutely. And then when we run, what's my run going to go by?
1s.
Yes, very good. My run is going by 1s. My x-axis is going by 1s. So I'm going to run to the right. 1, 2, 3. So my run is a positive 3. And then we simplify this. What's 9 divided by 3? 3. So, to answer the question, the cost per rose is $3 per rose, according to this graph. Now, anybody have any questions?
No, it was like 1 going over.
Based on the axis. Because the x-axis is going by 1s. 1, 2, 3, 4, 5, 6, 7. Whereas the y-axis is going 3, 6, 9, 12. Does that make sense? Yes, so you have to, that's why the very first thing I did was circle this stuff. To remind me to look at the
So if
excellence.
you went left, it would have been.
Yes.
By that? Okay.
Yes, exactly. But all of these that we're doing today are going to be positive, if I'm not mistaken. Let me check. Yeah, every one of them are going to be positive today. Okay, but yes, if you were to go left, yes. So let's do 2 other pretty points. Yes, do you have a question?
Could you technically look at that one and see what number?
Absolutely, very good. Good catch. So what you could do is you could literally look right here. Okay? That is the unit rate. 1 rose is $3. And then you didn't even have to do slope. Yes. But sometimes you won't be able to see that on the graph. Like sometimes the graph won't go by ones and you won't be able to see it. Or like on number 3, if you look at the 1, you don't know exactly what that number is because it's like halfway-ish. You know what I mean? You'd have to guesstimate. But if it is a pretty point where the 1 is, that's absolutely your unit rate. And you could say, boom, it's $3 per rose.
Well, I can't wait to get to the other point, 'cause I don't know how to do it.
Okay. Very good. So either you can, but the thing is you have to understand that slope is the same as unit rate. If you remember that, then yes, break it down to per one thing of whatever you're talking about. Look at it on the graph. If you can see it on the graph, boom, you're done. If you can't see it, then you do rise over run. It's like the backup plan, essentially. All right, now I do want to show you if I were to pick other pretty points. So like so let's say I pick this one, and let's say I pick the one that is that me? Is that my phone? My bad. Let's say I picked 927 as my other pretty point. Okay, and then I rise over run between these. You will get the same thing. It's just got to simplify to get that. You ready? So we're going to go, I'm going to count, let's see, 1, 2, 3, 4, 5, 6, 7, 8, and then I'm going to multiply that by 3. So that would be 24, right? 3, 6, 9, 12, 15, 18, 21, 24. So I rose 24. And then I'm running 1, 2, 3, 4, 5, 6, 7, 8. And 24 divided by 8 still simplifies to give you 3. So no matter what pretty points you pick, you're still going to get 3. Make sense? Give it that. Y'all are connecting a lot of dots on this first example. Very good. So the next ones will come a lot quicker. All right, number 2. The cost of the number of, so first thing I'm going to do is pay attention to my x-axis and my y-axis. The cost of the number of boxes of chocolate sold at a chocolate shop is shown on the graph. Is shown. Shouldn't have the second is shown. Is shown on the graph. So we're comparing the number of boxes of chocolate and how much they cost. Okay, so to find the rate of change, I'm going to try to find the cost per box, right? Earlier it was the cost per rose. Now I'm finding the cost per box. Okay, so we could do like Bella said. If we're finding the unit rate, how much, according to the graph, how much is 1 box of chocolate?
$6.
Is it 6? 1 box is, it's here.
I see it.
So how much is 1 box?
$12.
Yes, $12. So you could stop right there and be done. Okay.
$6 just for being free?
I guess. For like a half of one, I guess. Half a box.
No, it had to be with the line.
Yes, on the graph. Yeah, not on the grid. That's like the graph paper, like the blue graph paper. It's got to be on the thick black line. Yep, that's what we're focused on. And then just for funsies, let's go ahead and find 2 pretty points and do slope, just to practice slope. Just to practice rise over run. Alright, so we got 1 pretty point. What would you like the other pretty point to be?
24.
You got to do the X first.
Oh, yeah,
224. There we go. That's fine. Alright, now we got to pay attention. When I rise, what am I counting by?
6.
6's. So this would be 6, 12. So my rise is 12. My run is going by how many?
1.
It's going by ones, so it's just running 1. And 12 divided by 1 is 12, which is what we already knew. $12 per box.
Wait, how do we get 12?
The rise,
From
Oh yeah, the rise doesn't. Okay. Yeah. I'll say.
because it's counted by 6s. The rise is 6, 12. 6, 12.
Oh,
Then it's just 12.
if you're going left with a run, would it still count as like going 1? So you plotted at 12?
Yeah, I plotted I plotted a point at 112 and then 224. Just to practice the rise over run.
Oh.
You said we won't have to go left on any of these.
No, all these you'll be rising up and then running right because they're all positive slopes. Because in most cases, in real world stuff, it's going to be positive. The only time you're going to have where the rate of change is negative is, let's say, a business is losing money. So you start at what they're, yeah, exactly. And then going into debt, you can start at what their bank account is in and see how much money they're losing per month. And it would be negative in that case. All right, any questions about that? Good? All right, 2 more examples and then the back is for homework tonight. All right, so a bakery sells heart-shaped cookies in packs. Oh, so we're comparing the number of cookie packs to the cost again. So what is the rate of change? So here we are finding the cost per pack, per cookie pack, right? And like earlier, we looked and we could see exactly how much one box of chocolate cost. But here, can you see how much 1 pack of cookies cost?
No, because the line goes straight.
Yeah, because the line's like here, and I don't know exactly where that is. Does that make sense? So I can't just look at it to find the unit rate in this case. In this case, you have to do rise over run. Okay? There's no other choice. So let's do it. So to do rise over run, we have to find 2 pretty points. So anybody see a pretty point?
6 and 45.
645. Okay. And we need another one. 860. Cool. All right. Let's rise over run between those. So when I rise, boop. But what am I counting by on this one?
15.
Yeah. So if I rose up, that would just be 15, right? And then I'm running and counting by what? Count by 1. So I'm running 1, 2. So my run is 2. Are we okay with that? Everybody see where 15 came from? Where 2 came from? Alright, and then what is 15 divided by 2? And it's okay if this is a decimal because we're talking about money.
7 point something.
Yep. Y'all have calculators. It's $7.50, right?
I don't know.
Come on, think about it. Half of 15. Okay. Halfway with 14 is 7. And you got an extra one. Half of 1 extra would be a half.
You
So
just need
$7.50. Good with that? Alright. So the cost per pack is it's $7.50 per pack. Per pack. Ta-da. So if you're just having a graph, leave the slope as fractions like we did yesterday. But if we're talking about real world stuff and it's fine to represent whatever it is as a decimal, like money, then you can do it as a decimal. Alright, last one for notes. A candy shop sells bags of candy hearts. The graph shows the total number of candy pieces based on the number of bags. So what's the constant rate of change? So we are comparing bags of candy to the number of pieces. So now it's not cost, right? So bags of candy heart and the number of pieces there. Okay, so we're looking at the number of pieces. Number of pieces per bag is what we are calculating. Instead of doing the cost, we're doing the number of pieces per bag. And once again, can you look and find the unit rate at the graph? Can you see how many pieces are in one bag?
16.
Yeah, it looks like it is to me. Looks like. Oh, did I say it wrong? Sorry. How many pieces per bag? My bad. My bad. Okay, so yes, according to this, there are 16 pieces in a bag. If I can talk right. And then just for funsies, let's confirm it by doing slope. You do not have to do this. If you can see it, say the answer and keep going about your business. But for now, we're going to prove that we're correct doing rise over run. All right, where's another pretty point?
30.
No, say the X value. Yes. 232. Very good. Okay. Yep, 232, which makes perfect sense. So when I rise, I'm going to rise, and we are counting by what? 4. Yeah, so 4, 8, 12, 16. And then we run how many? 1. And 16 divided by 1 is 16, which is what we got. Yay! So that's applying your knowledge of slope to real world scenarios where the graph isn't just one going by ones anymore. Sometimes it goes by 5s, 10s, 6s, 4s. So you got to make sure that you pay attention. Okay? Good with that? Any questions? You did very well. Nice job.